Okay, let us continue. There was a momentary technical problem and we are back. Okay, let us go to the next slide. So, hypothetical word. The first bit is used for the sign of the number. That's why it is usually 8-bit. And it becomes 9 because the ninth bit is the sign of the number. Either it is positive or negative. So, the second bit for the sign of the exponent. Okay. The next 4 bits for the mantissa and the next 3 bits for the exponent. So, take a look. Okay. The first bit is for the sign. Okay, what is that? Sign of the number. The number is different from the exponent. So the first bit is sign of the number. The second bit is sign of the exponent. Okay, and the next 4 bits, mantissa. Okay, and the next 3 is the exponent. Okay, so it looks like this, no? It looks like this. Okay, so sign of number, this refers to the first bit. The second bit, sign of the exponent. Then the 4 bits that follows, it is mantissa, and then the last 3 is the number of exponent, the exponent itself. So there are what? 9-bit hypothetical word. Okay. So every number could be represented by this, by this 9-bit hypothetical word. Number usually is the one being represented by this. Okay. So I would remind everyone to turn off or mute your sound. This video lecture is being recorded for future use. Any question about this? So this is how they locate where is the sign of the exponent. So since in this example 5 is the exponent, 5 is the exponent here. Okay, the exponent is 5, but 5 is positive. That's why the second bit will have to be 0. 0 means positive. Okay, 0 means positive. What about the number? The number is also positive here. The number is positive. So therefore, the sign of the number is also 0, which means positive. 0 meaning positive for the number. Another 0, the second bit, is for the exponent. And this the 4 bits here is the mantissa. Okay, 1 0 1 1. 1 0 1 1. Okay. So let us try to use our calculator. Let us try. I will try our calculator if that is possible. Where is the calculator? Here. Okay, here. Calculator. So, what is the given? The example is 54.75. Okay, 54.75. So let us 54.75. So please bear with me because I am also learning how to use calculator. So let us, I think this one, the green color here is binary. Okay. So how to do it? I think mode, no? Mode 4. Mode 4 is decimal, no? You cannot do it, no? However,
Sir,
we have
try nyo po yung alpha po.
the knowledge how to do it manually. Okay, so I am just looking at how to do it in calculator. We know how to do it manually. We already have a video lecture on that. Okay. So color green, no? There is no color green. Actually, I have yet to use this binary because I do it manually. One equals. So delete. So ilan yun? 54.75. So point. Hindi siya nalalagyan ng point, no? Hindi siya nalalagyan ng point. Okay. Okay. I don't know how to use this. You have to use the actual calculator. It's a first time experience for this application. Cannot find it. Okay. So that's maybe the way to do it. So shift. Okay, for example, decimal. There's no here. Decimal. Okay. For example, 54 in binary. So, that is not correct. 54 is not equal to 54 in binary is different, no?
Sir, pindutin nyo po muna yung equal po, sir, para po lumabas po yung sagot ng binary po.
Okay. That's correct. So, 54. So hindi pwede, no? So I can do it in the real calculator. Because ito muna tayo. 54 times, wala siyang quad. Okay, let's return. Let's return to normal. So 54.75. Hindi ba ito rito? So, magbe-base 10 siya. So, binary. I have to search for the green one. There is no green. Okay, this is the reason why we have to learn using calculator. And each and every brand of calculator, they are different. So, let's see.
Sir, try niyo po, sir, sa ano po muna, sir. Sa mode, tapos base M. Yung number 3 po.
Mode.
Yung 4 po, sir, base N.
Okay, yan yung ginawa ko kanina.
Tapos po, sir, input po kayo, sir.
Okay. Input natin. So, hindi
Wala
pwede.
po siyang point, sir.
Walang
Pero,
point,
sir,
diba?
opo, sir, ayaw po may point. Ganun din po ginawa ko sa akin, sir.
Walang
Bali, sir, pagkatapos yan, sir, mag-i-equals, tapos pipinutin po yung binary. Lalabas po yung binary
okay.
po yan. Tapos binary po.
Okay, so binary.
Yan po. Bali, ayun na po yung lalabas. Yung simula po sa 110110, ayun na po yung binary na
110110. Okay.
Yes po, sir.
110110. That's correct. That is the correct answer. 11010. But that is for the 54. Okay? That is only for the 54. 110110. Okay, that is correct. So tanda natin, let us familiarize. So any number, for example, 54. So I will start with, this is your normal calculator window. Then you have to go to the mode 4, that is, so mode 4 immediately will go to decimal. And then, so when we are in the decimal, you have to input the number and then equals. So it will become decimal 54. But our calculator cannot be used for with decimal point, no? So this calculator is only for integers. Okay, so binary, just click the binary. Okay. If you want to be back to decimal, click the decimal. So because we are in the mode 4, only the green buttons will be used. Okay? Decimal, hexadecimal, binary, octal. So because we are in the mode 4. So mode 4, binary or hexadecimal. This is the hexadecimal. If you convert to binary, this is the binary. However, I am looking for the decimal point. That is not possible in this type of calculator. So we still need to do it manually. The decimal part, no? The decimal part. So how to do it? The decimal part, the decimal point is 0.75. What will you do? Multiply by 2, multiply by 2. Continuously multiply by 2. That is how we did it the last time. The last time when we lecture about the binary. Okay. Fine. The integer, converting to binary, we have to divide by 2. If the decimal point, we have to multiply by 2. So 0.75 times 2, what is the answer? 1.5. Oh, there is 1. And then 0.5. 1 and 0.5. So 0.5 times 2, that is 1. So that's why the decimal point, 0.75, is actually 1. Take a look here. I will go back. I will go back to sharing the other one. Okay? So take note, take note. Our answer is what? What is the answer? 110,110. Take note. Please note it in your scratch paper. 110,110. And I told you to convert 0.75 by multiplying 2. And again 2. So 2 times. The answer is 1. Okay, the answer is 1. So we will put 1 at the next digits here. So what will happen is 110, 110, 11. That is the final answer. So let us go back to the screen. That is how we do it manually. It is even faster for me to do it manually rather than calculator. Okay? Because I am not practicing using calculator. That's why you have to practice using calculator. Okay. Important thing, you have to use your calculator always. Okay, let us go back to our take note. What happened? 110, 110, then 11. So we are correct. We did confirm that our answer is correct. 0.75 is equal to 0.11. Okay? And therefore, you have to convert this into scientific notation like this. Scientific notation. How many digits? 1, 2, 3, 4, 5. That's why the exponent is 5 here. The exponent is 5. That is positive. That's why it is 0 in the sign of the exponent. And the number itself is positive. That's why it is 0 in the first digit of the number. So the final answer is 0, 0, 1, 0, 1, 1, 1, 0, 1. Okay. So because after converting this, you have to convert the 5. 5 is what? 101. 5 is 101. If you convert 5 into binary, that is 101. Okay? Any question? You can use your calculator because 5 is an integer. It can easily be converted into, so 5 is an integer, that is, I will show you again. Let us go back to the calculator. So, decimal. Let us go to decimal and 5. What is 5? 5 is our exponent. We would like to convert this into binary. This is 101. So convert to binary. Press C equals, then binary. Look, 101. Okay? The leading 0 do not have any value because these are all 0. So the only digits that matter is 101. So 5 is 101. Okay? Take note. So let us learn to use calculator. Very important. Very important. You have to know and familiar with your own calculator. So I am also familiarizing myself into what? Calculator application. This is not a real calculator. So let us go back to our shared screen. Okay. So next page. Any question? So next page.
Sir, pwede po paulit yung dun sa ano po, sa 0.75 kung paano po nakuha.
Multiply by 2. Multiply by 2. Everybody can review previous topic, previous video regarding binary. Okay. Okay. I will show you using calculator. Okay. Using calculator. So that is manual. Actually, manually. Not using calculator. So the decimal point, let us go back to what? Mode 1. Okay. So 0.75 is the decimal number. Okay. 0.75. Just multiply by 2. Okay. What will happen? This is 1.5. Okay. The number is 1.5. So this is in fraction. Okay. Why this is in fraction? Okay. Let us put this. Oh, that is 1.5. Okay. If you multiply by 2, 1.5. So the answer is 1. Okay. The answer is 1. What is the remainder? The remainder is 0.5. Okay. So the remainder is 0.5. So remainder. Again, multiply by 2. Okay. What is the answer? 1. That's why 0.75 is equal to 1. Okay. Okay. Is that clear enough? Is that clear enough?
Yes, sir. Clear na, sir.
Okay. So let us go back to the... So 0.75 is equal to 1 because of manual computation. Let us go back. Okay, so machine Epsilon defined as the measure of accuracy and found by difference between one and the next number that can be represented. So definition, take a look at definition. That's why you have to be very critical of the method. When we are explaining example, be attentive. Okay, 10-bit word. Previous slide, that is what? 9-bit word. Now 10-bit word. What happened? Instead of 3 digits for exponent, we have what? 4 digits for exponent, another 4 digits for mantissa, and 1 each for the sign of both the number and exponent. So the total is 10. Okay, so machine Epsilon. Okay, machine Epsilon is equal to this one. What is 1.0625 minus 1? So this is the, okay, for example, okay, base 10. Okay, now next number, what is the next number? 1. Okay, if you are counting from 0 to 9, that is base 10. From 0 to 9, base 10 is, you have to count from 0 to 9. That is base 10. Okay, so you will start with 0. So this is 0. Okay, is 0. The next number is 1. Okay, the next is 1. So if that is the case, the epsilon or machine epsilon will look like this. Okay. So this is a binary. So this means binary number. This means decimal number because we have what? 10 as a base 10. So decimal. Okay. So machine epsilon is like this. So just remove the whole number here. So remove the whole number. What would be left is 0.625. Okay. And that is equal, 0.0625 is equal to 2 to the negative 4. Okay. Okay. Familiarize yourself with that. No? Because if you are doing that repeatedly, you will immediately familiarize your eyes. You can familiarize your eyes that 0.0625 is equal to 2 to the negative 4. Automatic. No? Automatic. Just taking a look at that. But if this is your first time, do not expect yourself to be able to recognize it just like that. No? You have to what? Compute manually. By what? Again, times 2, times 2, times 2, times 2. Just like what I did. No? Just like what I've shown you a while ago. Okay? Okay, relative error and machine epsilon. The absolute relative true error in representing a number will be less than the machine epsilon. So that's why machine epsilon is important because it shows us some limitation. Machine epsilon is limitation. Okay, for example, 0.02832. Okay, convert to binary. Cannot be done by our calculator, manual. No? What will happen? Multiply by 2 times 2 times 2 times 2. And then convert to the scientific notation in binary form. This is a scientific notation in binary form. Okay? Okay. Then, you have what? Exponent, which is negative 5. So convert this into binary. Again. So negative. Okay? Okay. And then 5. So convert. Aha. What happened? So, okay, let us continue. Continue. So there is a formula in computing the relative error. Relative error is epsilon A. So is equal to, what is 0.02832? That is our given, no? Here, minus 0.0274375. What is that? Here. This is what we got from this operation. So we operated here. Then if you convert this into decimal, this is what we got. Then what will happen? Relative. You have to subtract. you have to subtract this into from our given number. So subtract and then divide by the given number. That is our absolute. It's our absolute relative true error. This one is absolute. So our absolute relative true error is 0.0625, which is actually equal to 2 raised to the negative 4 binary. Okay. 0.0625 is equal to this one. Okay. So 2 to the negative 4. That is from binary to decimal. That is the decimal equivalent. If you compute that, that is equal to 0.0625. Okay. And then the floating point standard is defined in the document. This is the document that defines floating point of the computers. What do you mean by IIEE? Institute of Electrical and Electronics Engineers, 754. 754 is the number of standard. This document is the standard for single precision representation. Okay, how our computers and digital gadgets like your cell phone works. That is how. Okay, that is the definition. How it works internally, inside the gadget. Okay, inside. So we do not need to go deeper into that. Just the idea, because we are civil engineering. If I am the teacher for electrical engineering or electronics engineering, we will go more deeper, deeper in this regard, because that is the major subject of electronics and electrical. But we are civil engineer, we just need an idea. Okay. So floating point is standard. That is the standardization of floating point numbers on different computers in single and double precision. So it defines the representation of floating point operation on different computers. That's why different computers are able to communicate with each other. Different cell phones are able to communicate with each other. We can send data. Okay? We can send information. We can send text. We can chat through cell phone. However, in actuality, the cell phones communicate with each other using binary in actual. Okay? But we don't know. We don't see. What we are seeing are the text messages in our chat or in our GC. Okay? That is how digital gadgets and computers work. Using floating point. Floating point meaning the point, the decimal point is floating because it could be placed anywhere. And actually, we are placing the point after one digit. After one digit, we are placing the point, and that is what we call, in our discussion, that is what we call what? Scientific notation. Okay? Scientific notation is the type or the format wherein you express numbers with one single digit of integer, then point or dot, then another series of numbers. Okay? So times 10, if the number is base 10, times 10 to the exponent. But if the number is binary, times 2 to the exponent. Okay? Same idea. Same idea. We are talking about human being times 10 to the exponent. If we are going to imagine what computers are doing inside them, how they communicate, how the laptop communicates to the other device, so that is in terms of binary. Okay? What every engineer and even you are not should know about floating point arithmetic. Okay. So we need to know the concept. We do not need to know more than that because we are civil engineering. Okay, so we have an example, 32 bits. There are still computers and software that will run on 32 bits. The new ones, the new laptop, the new desktop computers are now 64 bits. Okay, 32 bits for single precision. How it is represented? The first digit is signed. The next how many digits? 8 digits. The next 8 digits is what we call biased exponent. Okay, it is not just exponent, but it is biased exponent. So the next or the rest of the digits are called mantissa. So this is the format of the 32-bit computer. But now we have what? 64-bit computer. For example, what is the difference? 64-bit computers would run AutoCAD or the CAD and CAM application software faster than if the laptop is, for example, 32-bit. The 64-bit laptop could run the same AutoCAD version faster than a laptop with 32 bits. Okay, that is the concept. Because of this, because there are so much information in 64 rather than 32. There is so much information in 64. Okay, and in terms of video card, 64-bit would play your video smoothly than a 32-bit. So if you already know the 1K and 4K, 4K is the current standard of video right now. The best video quality is 4K. If you can play a video in your laptop, the 4K video smoothly, then your laptop is good. Maybe my laptop is not, and maybe my laptop is made in. So if you can play smoothly the 4K, maybe your laptop is made in Japan, no? But my laptop